Hello, Java coders. Tonight we're going to take a look at chapter 20, list stacks queues, priority queues, as you can see. Basically what we're looking at here in this chapter and the next chapter are some data structures that we can use in Java to organize the data that we have for our application. So what you want to do is you want to go to our course page and get the zip file that's relative to this chapter and the Word document. And I'm going to start by going through that Word document. And here it is. I hope you can still see that okay.
Sure.
Make it a little bit bigger. Collections. Collections are objects that organize other objects, usually of the same type in Java. The various objects in a collection are called elements. We can't use primitive types. Okay, this is only for reference types, only for object types. So you can only make Java collections with classes, not with ints and doubles and floats. If you did need to use integers and doubles, you would use capital I integer and capital D double.
Those are called wrapper classes, right?
That's right. That's right. Because you're basically putting a wrapper around a primitive int to make a capital int integer. Yeah. Okay. Now, all of these are organized into what's called the collections framework, and it consists of interfaces, implementations, which are concrete classes of those interfaces, and some static methods. And we're going to see that there are three main kinds of collections. Sets. A set is a collection with no duplicates. I don't know if you've ever collected anything like maybe baseball cards or whatever. If you collected a set of baseball cards, once you had a complete set, if you were ever so lucky as to get that, well, if you had any double cards of the same player, then that would be a trader that you could use to try to finish up your set. But once you had the whole set, you would probably put an elastic band around it or something and put it in a box, and you had a complete set. No duplicates. A list is a collection of elements where duplicates are possible, and lists are ordered. They're, as you know, they're indexed like arrays are. And then we also have maps, which we'll see later on coming up. So we're going to actually cover maps and sets in the next chapter. Maps are somewhat like dictionaries in Python, if you studied those. Now here's a diagram that I found online that's superior to the one in our textbook that shows you what the collections framework is. In our textbook, we have one on the next page. I believe you'll see. The collections framework. There's the collections framework, but that's actually not nearly as good as is the one in the document here. This is far more complete. And as you can see, it's not trivial. I mean, all this had to be worked out by the folks at Oracle, or actually at Sun Microsystems, I guess, originally, and then the people at Oracle. So that's how they coded it, and I color coded everything here so you can see what's what. Okay, here's the textbooks example. So it starts off with the collection interface over here on the left. And it's the superclass of the whole collections framework, CF for collection framework. And it has the core methods common to all collections. And as you can see, it's the parent of many other classes. Now, usually coders are going to use these concrete classes. You see the vertical lines here that breaks this up into three sections. Usually you're going to be using these classes over here. Okay.
And Mr. So collection is the base class for all of the other classes over here?
Yeah, that's right. Notice the arrows pointing at this one?
Yes,
that's
sir.
Right. Yeah, that's the super class. Yeah.
So abstract collection, that's a subclass of the collection superclass.
Yeah, that's right. This is actually an interface, not a class.
Oh, good. Okay.
Yeah.
Okay, I get it.
Okay.
Thank you, sir.
No problem. So the first example that Liang has for us is called test collection. So fire that up, and in your Eclipse, if you import chapter 20 zip file, you'll see that test collection is in there. And here it is. So let's see what's going on here. What do we got? We're going to create an array list. Well, an array list is one of the classes, one of the concrete classes in the collections framework. And this is going to be an array list of strings, where the strings are city names, as you can see. And we can then print them out. Now, if you actually just print the name of the collection, you get kind of a crude output. It just dumps it out with the square brackets and commas in between them. Not something that you're usually going to want to do in an application. But if you ever want to see what's in your collection, you can just print the name of the collection, and it'll dump it out onto the screen like that. Now, we've got a contains. There's a contains method that applies to see if a particular value is in the collection. So we're going to see if Dallas is in the collection, and in our output. And you'll notice we got a true for that because Dallas is in the collection. And now we're going to remove Dallas with the remove method. So Dallas is gone. Now the size, there's a size method that tells you how many elements are in the collection. And as you can see, we're now down to 3 after we got rid of Dallas. Now we would look at a second collection of strings with some more city names called collection 2 with some different cities, although not all different, you know, so we also have Atlanta in this one. And we're going to print that out just by dumping it on the screen. And that's what this is, the output of line 29. And now we're going to use the clone method to create an exact copy of collection 1 called C1. And then we'll add all of collection 2 to C1. And then we'll print that out. Cities that are in collection 1 or collection 2, and print this out here. So by adding them, we now have cities that are in collection 1 or collection 2 in this C1 collection. And you notice we did get more cities. But it did also include Atlanta twice, as you can see. So you can't have duplicates in an array list.
Mr. Good, array list is an object type, right?
Oh yeah, oh yeah, yeah, absolutely. Okay. Whenever you see anything with a capital A, you know that it's a class, and that means when you create an object of type array list, it's an object. And now we're going to use remove all with collection 2. And basically it's going to be the cities in collection 1, but not in collection 2. Cities that are in both is the Atlanta. Sorry, I messed this one up here. Retain all shows you which is in both collections, and only Atlanta was in both. And now we want to get a list of with remove all here of cities that are in collection 1 but not in collection 2, and that would be these two here. So there's just quite a few methods. This is actually mostly about some of the methods that look like they're array lists, but they're actually inherited from the collections interface. And I think if we take a look here, yeah, here's the collection interface, and you can see here's all the methods here. So it looked like we were using array list methods, but in fact, we're using the ones that were inherited from its superclass, or the interface that it inherits from, which is interface collection. It's the collection interface.
Monsieur, could you go back to the program example?
Yeah. Okay.
So we are using the interface class methods.
That's right. We're using methods that are in our array list, but they were inherited from the
On the,
collection interface,
okay.
like the add all and the retain all, for example.
Monsieur, Arraylist is an object of is an object type of subclass of the object class.
Well, everything is a subclass of capital
Of
O
the
object.
object class.
Yes, everything is. Yeah, that's the way they design Java. Every class in Java is a subclass of capital O object.
Okay.
Okay.
So Arraylist is an object of the capital O object class. Okay. Got
Yeah,
it. Thank you.
everything is string. You know, the string class, that is a subclass of capital O object. Everything, and even the classes that you make when you design a custom class like automobile or
Mhm.
car, it's going to be a subclass of capital O object.
Capital O. Got it.
Okay. All right, so just going back to the document here. So what we were looking at were there's a lot of the methods there in that example. Now there's also an iterator interface, and you can use this to iterate over the elements of a collection. Iterate means loop through, right? Go through them one by one for the elements of a collection. And it has three methods. It's got a has, next, and remove. Has next, you can tell by the name of that method, it's going to return true if there's another element left in the collection. And the next method will actually read that next element in the collection. So think about, as you're thinking about an iterator, think of it as a pointer that's moving through the collection one by one, element by one. It's advancing through the collection. And that's what the next method reads each one. And we've got an example called test iterator. Let's have a look at that. Look at test iterator. Here it is. And Dr. Liang here is working with the same collection. Okay, this time he just called it collection. He didn't even bother to create an array list, except he did over here. Okay, so the actual type is an array list over here. And he's going to add these cities to the collection called collection. And now he's going to iterate through it by creating an iterator. So you actually create an iterator for strings. We can call it whatever we want. It's been named iterator here. And then you take the name of the object that you want to iterate over and then dot iterator. That's the syntax that you need to use. Then what you can use is while iterator has next to go through it one by one. And as you do go through it by one, you want to use the next method. In this case, we're going to change them all to uppercase. You don't really have to do that, but we're just going to chain the to uppercase method to the next method so that the city names will come out in all uppercase. And then we can also remove the last one that was iterated over, and then we'll report the size of the collection. So when we run this, you can see it goes through New York, then Atlanta, then Dallas, and then Madison. But then it erased Madison, so we're now down to just 3. So at the end of the program, only these 3 were in the collection. Okay, so this line here is kind of, I guess, one of the tricky lines. When you have a collection type object called collection, to get its iterator, you use the name of that and the dot iterator method. And you have to create an iterator of the proper type inside the curly braces, which of course is strings in this case.
And we could have used that iterator to iterate over any type of object.
No, it has to be a collection, something that inherits from the collection interface.
No, I meant like instead of string, we could have used we couldn't have used an object type of a different.
Oh, instead of string here? Yeah, like we could have automobiles or something. Yes, absolutely.
Oh, okay, okay.
Yeah,
Okay.
yeah, this class type could be anything. Maybe a class that we make, right?
Yes, yes, that's
Could
what I
be a
was
custom class. And
Okay.
we will be doing that.
Okay, got it. Thank you, sir.
Okay. So going back to the document here. Yeah, notice it's the iterator method that returns an instance of the interface iterator. That's that line I was trying to show you. Now, you take a look at 781. They introduced the var for declaring a variable on page 781, and it deduces its type from the context of whatever you're working with. I like to kind of avoid it because you won't even see it in some textbooks. So I'm not going to push that one. But one that is very useful here is this for each method on page 782. If you take a look at page 782, and we'll try to do that in the ebook here. Go ahead a page or two. And you take a look at page 782. I guess it's 783. Yeah, here it is. So it's 7, 8. Oh, no, I am 782 here. Sorry. Yeah, for each method. So once you have created something that inherits from collection, in this case, an array list of strings, you can use the name of the collection and dot for each and a lambda expression to go through it one by one. So that's pretty cool. So you don't have to use a for loop yourself. You can just use the for each method, which generates a for loop. Pretty cool. The for each method, that's new in this chapter. And we've got one we can take a look at called test for each. Let's have a look at that. Test for each. Get to it here. Here it is finally. All right, test for each. Yeah, it's actually pretty straightforward. I'll give it a quick run. You can see it'll just print each one, but it's going to convert them to all uppercase. So that's interesting. So what it means is you don't have to create your own for loop. You don't have to do this. You don't have to say string s in or string s in collection system out dot print line s. So instead of this, you can just do this now.
The E in the for each statement, Mr. York, that's the element, I'm guessing.
Yeah, that's what you. It's the object that you're working through.
Okay, collection. Collection
Yeah.
for each. Okay. I understand.
Really, do you remember when we first talked about event handling and we said that we had to have an event handler? Well, this is it here.
Okay. I get it.
So if we run this here, we get the cities twice, but I didn't put a new line in between them here like I should have done. So put a blank print right here, we'll get two separate runs, one lowercase, one not lowercase. That's from the enhanced for loop, right? We call this an enhanced for loop. Well, they introduced this to make it even easier, which is kind of cool. Okay, I hope you're all right with that. And where that came from, we'll get rid of it. And we'll go back to our document here. List interface. Well, we've already been working with lists, particularly Arraylist, but there is an interface in the collections framework from which both Arraylist and Linkedlist, for example, inherit. And a list is an ordered collection. Each element is indexed starting from 0, as you know. You can have duplicates and you can have null values. They all have to be the same type, though. You can't mix different types when you create a list. It extends collection and includes all of its methods. So when you're using an array list or a linked list, all of those methods that are in the collection interface are also available to you. But each one of these classes has its own methods. Page 783 will show you that. We can get back to the ebook here. Which I may have just lost the ebook, unfortunately. But if you take a look at page 783, you'll see there a UML diagram for the list interface showing you some of its methods. And we'll see if I can get back there to that. Don't really want to create a course. Just logging back into the ebook here. Okay, so there's that for each method. And if we go ahead a page, here's the list interface. Now notice that there's a list iterator here. The list iterator. It's kind of like an iterator, except it's specifically for a list. And what's interesting about it is you can go forwards or backwards with a list iterator. So let's go back to the document here for a minute. List iterator. It's for iterating forward or backward through a list. So as well as having a next and has next, there's a previous and has previous for working backwards. You cannot make a list, but it does have concrete subclasses. This is an interface, right? So you can't make a list object, but you can use it you can implement it in a concrete class. And the concrete classes are Arraylist and Linkedlist. And the best way to see that is back right here. If you look at, here's the list interface, and beneath it we have abstract list, and beneath that we've got a couple of other, as you can see, the abstract list interface here is, our abstract list class has a subclass here, but it also has subclass vector and array list, and here's linked list. So these three here are your list concrete classes, as well as stack. So with that in mind, let's take a look at the array list. Now we already know all about array list, but it has a class that's very similar to it called vector. And vector is like an array list, except vector is thread safe. Thread safe. Now, if a class is thread safe, what that means is if you have multiple threads trying to access the same object, only one can access it at the same time. That makes it thread safe. So one thread gets exclusive access when that thread is through with the vector and releases its connection, then another thread can connect and work on that vector. Array list is best when you need to access an element by index, unless you need to insert or delete at the beginning or end of the list, when linked list is a bit more efficient, they say. We haven't looked at linked list yet, but we will. Array list has a get method that's not efficient. Better to use an iterator if you want to work for speed. But you can also use a for each loop because it uses an implicit iterator, as indicated on page 786. So let's take a look at array list 1. Now this is one that I made up for us. We take a look at array list 1. We've got here somewhere. There it is, array list 1 at the very top. Okay, so we're going to make an array list of strings called COL, and we're going to add COP2251, Java 2, this course rocks. As you can see, those are all strings. And we could go through it with a for loop. This is a traditional for loop, as you can see. We can go through it one by one using the get method to access each element in the array list. But we could also use an enhanced for loop like this, or we can use a list iterator. So once again, what we do is we create a list iterator for strings called IT. Here's our object, and then we run the list iterator method, and that makes the list iterator object called, in this case, IT. Just changed it. We want it to be IT. So now we can then use it while IT has next, print IT.next, and that'll access the next element in the list. But here's the cool thing about it. We can now go backwards. After we've gone through it forwards, we can now go backwards with IT has previous and previous to go backwards through the list. And then finally, we've got using the for each method here, which is, I guess, the most, the newest approach. So if we run this, we get a whole lot of output as we're going through this list in various ways. Using the list iterator, we got this, but now we can go backwards. So as you can see, we do get them in reverse order, each on its own line this time, but backwards. And with the for each method, it's the same as we got with all the others. So you got multiple ways that you can go through, that you can iterate through a collection, and in this case, it's an array list. You got multiple ways you can access it now. An old-fashioned for loop that we learned long ago in Java. You could use an enhanced for loop. You could use a list iterator. And you could also use the for each method. So you got multiple ways that you could go through an array list. So that's what that was about. Let's go back to that document for a second then. Now, linked list. Let's take a look at linked list. Here's a depiction of what a linked list is. A linked list is a collection of objects, only for objects, right? Only for reference types, where each element of the list has a connection to the following element in the list. And this is a linkage. You can see it's like a linked list here, like a chain. It's an ordered collection, and you create them with class linked list. Each element, except the head, has two parts to it. It has the data plus the address of the next element. Notice here, this is the address of the next element. So that's the connection there. The first of the list just has the address of the first element. Linked list can grow in size. And interestingly, you can do insertions in the middle of the list too. Duplicates are allowed, as with all lists. And you've got that list interface. You got a lot of methods that you could use from that list interface, because this inherits from, this implements that interface. Now, we don't cover it, but there's also doubly linked lists. So I've just inserted a diagram here to show you what those are like. In a doubly linked list, each element, as well as pointing at the next element in the list, also points at the previous one. Now, what can you do with a linked list? You can create other data structures like stacks, queues, trees, and double-ended queues. That's what this is, DEX. DEX means double-ended queues. An iterator is more efficient for traversing a linked list. It's faster. Iterator doesn't have an add method, but list iterator does. So with list iterator, you can actually add a method as you're going through the list. For example, you could iterate through the first 3 elements of a 10 element array list, and then you could add on another element at that point. You could insert at that point. If you use the add method, it will add the new element before the current position of the iterator. So once again, you always want to think of the iterator as kind of like a pointer that's advancing through a list one by one. We've got an example called linked list 1, and we also have test array and linked list. Let's take a look at linked list 1 here. Here it is. We're going to make a linked list of strings, and what we're going to put in that linked list are the names of some programming languages, as you can see here. So we added Java, Python, C++, and then we also use the, after printing those out, which will just dump it on the screen, we can add another one, JavaScript. And then we can create an iterator, and this actually is going to be a list iterator. We'll call it iter. And to do that, we just take the name of our object up here, langs, and dot list iterator. And now we can add another language, Ruby. And since it's an iterator, a list iterator in this case, well, we can use the hasNext method to go through it with the while loop and print them out. And then we can go backwards with has previous and previous methods. And we can also indicate the size of our list. So when we run this one, it comes out like this. There's what you get if you just print the name of the collection. It's kind of crude output, but if you want to use an iterator, then you can get much better output.
Mr. Yurt, so this was a linked list, right?
That's right.
And if we used an array list, we could have used, could we have used the add method for that also, right?
Yes. Yes, you could. Yeah.
Okay, so the only difference about between array list and linked list is one is more efficient than the other.
That's right. Their structure is a little different, and because of that, their qualities are, their characteristics are a little bit different, as we shall see.
But both of them can implement almost the same methods
Yeah, pretty much. A lot of methods in common. That's true.
because they're objects of the same superclass.
That's right. And they implement that collection interface and also the list interface.
Okay.
Yeah.
Okay. So yeah, pretty
So,
much both
so
of
they
them will do this.
get those methods, right?
Okay, got it. Thank you.
Okay. All right. So so I get back to that document. Here we've got test array and linked list. Let's take a look at that one. It's one that we haven't tried. Test array and linked list. Here it is. And we're going to start off by making an array list of capital I integers. And it looks like we're just adding ints, but remember, they're auto-boxed into capital I integers. Okay, and we can also add more than one at a time if we want, as you can see here. So if we just print this out, we called it array list. If we just print it out, that's just going to dump it on the screen. Let's see what we get from that. Yeah, that's what we got right there. Now, if we want to go through that in a forward direction, what we can do is we can make a linked list called linked list, but this is going to be a linked list of objects. Capital O object. That means we could put any type of object into this linked list, because capital O object is the superclass of all classes. We could add anything onto this list. So what we'll do is we will add at index 1. That's one of the little differences with linked lists. You can specify the index where you want to put the particular element. In this case, we'll add that at index 1. Then we're going to remove the last one. But we're this linked list, by the way, I forgot to mention, we're making this array list. We're making this linked list using array list up above. So notice here in the constructor of our linked list class, we're specifying the name of the array list up here. So what that means is we're going to create a linked list from that array list. Then we're going to insert red at index 1. We're going to remove the last element, and then we're going to add green as the new first element in the list. And then we're going to go through the linked list forward in the forward way by using a list iterator. And then we'll go backwards through that same one. So when we go through the list of the forward direction, now notice, look, we've got strings and numbers in the same list. Very unusual that you'd want to do that in an application. But if we make our linked list of type capital O object, we can do that. We can add any type of object to that linked list. And as you can see, we've now we're going to go through it backwards, so it comes out in exactly the opposite order.
Mr. Yurt, I have a question.
Okay.
I'm sorry to keep interrupting you.
It's okay.
The output on line 2,
Yes.
the crude dump,
Yes.
is that, I mean, how is
That's from this.
that, why is 10 the first element and as the output?
Because it was added at index 0.
Oh.
Yeah, the add method for linked list allows you to insert. When you use add, you're actually inserting at any index you want. If you don't specify anything, it adds on to the end. But if you put in an index value in, it'll add it at that index. So you'll notice too that the 3 is, pardon me, the 30 is at index 3 right here. That's index 3, right?
Yes, sir.
0, 1, 2, 3.
Okay, I get it now. Thank
Okay.
you.
So you've got pretty nice control with an array list, actually. Okay, so I hope you're okay with why that worked the way it did. Now, this is very unusual to create an object type, but if you ever needed to do it, it is possible. You can add any object type to a list of objects. Now, here's something that's really interesting. The comparator interface. You may recall that earlier we talked about the comparable interface back in chapter 13. And we learned there that it has a compare to method that we can use for comparing objects of the same class. And that is useful for doing sorts, for example, right? And that's what we used it for, by the way. We used it to compare objects of the same class. Well, there's another interface called the comparator interface, which can also compare objects of the same class, but it can also work with objects of different classes. They don't have to be the same class. So we can use that for objects that don't implement comparable. So how does it do it? Well, it has a compare method. Instead of compare to, it's just called compare in the comparator interface. And we need to take a look at page 787. So let's see if I can hop there quickly to page 787. Yeah, here's a little bit about the comparator interface here. And it's generic. And here's an example of a geometric object comparator. Public class geometric object comparator implements comparator. So as you can see, we're going to implement the comparator interface for geometric objects. And in order, whenever we do that, we're going to be required by Java to flesh out or implement the compare method. So what we're going to do is we're actually going to compare geometric objects by their area. And the syntax is very much like what we had with the compare to method for comparable. We're going to have an if, an else if, and an else block to return 0, -1, or 0. It'll be 0 if they're equal. And we can use that to, we can use that for sorting, for example. And here's an example that does it, that Liang has for us, called test comparator. Let's take a look at that one, test comparator. Here it is. Pretty short, sweet example, which is nice. Okay, so let's see, we're going to create a geometric object called G1, which is actually going to be a rectangle. Now, there's quite a few classes in here that we haven't looked at. Here's geometric object. Let's just take a look at it. Geometric object, it's an abstract class, and it has these 3 attributes: color, filled, and a date. Okay, so those are the attributes. And the constructor is protected instead of public here, as you can see, and that's going to add the date. And here's another constructor here that's going to flesh out all the other values. So that's our abstract class called geometric object. Well, inheriting, we can use that to create concrete class, and one of them is class rectangle right here. Here's class rectangle, which extends geometric object. So by extending geometric object, it's going to have to, if we look back at geometric object, let's see here. It's got two abstract methods, right? Remember, if a class has an abstract method, that class has to be abstract. Well, in this case, geometric object has a get area and a get perimeter method, which are abstract. There's no body, just the method header. So in class rectangle, we have to implement both of those. So if we scroll down, and we'll see that, yes, we have here, as you can see, we have implemented them here by providing the code for get area and get perimeter. Okay, so that's class rectangle. Now, I think there's another one called class circle. Let's take a look. Here it is. Yeah, circle also extends geometric object. It has only one attribute, the radius, but it also has two constructors, a default constructor and a parameterized constructor, which sets the value of the radius. But it also, since it's extending geometric object, just has to have a get area and a get perimeter method as well. And here they are. Well, actually, get area is here, and get perimeter is this one's for the diameter. Here's the get perimeter. Now, if we didn't have these, we would be getting a warning from Eclipse that we have to implement this method. I'll just show you that. If I comment this out real quickly, I'll add a block comment there, and you'll see up here I'm getting a warning. Let's see what the warning is. Add unimplemented methods. See, I have to have the unimplemented method, which is the one I just commented out down here. So let's see if I can get that back. The way that comment worked was kind of weird. Yeah, it didn't quite work. Maybe if I format it, though, it will. Whoop. Should be okay if I source format it. See if we can do that again. Remove that comment. All right, we'll do it the hard way. Now this just needs to be formatted, so I'll hit source format, which should clean up the indentation, which it did. So we're back to good now. Now, so what we were talking about there, these are circle and rectangle extend geometric object. Okay, so in the example that we were taking a look at here called test comparator, we're going to create two geometric objects. One's going to be a rectangle and one's going to be a circle. And we're going to compare them. And how we're going to compare them, we're actually going to use this max method down here. Public static geometric object. So this method called max is going to return a geometric object. It's going to work with several geometric objects. It's going to work with G1 and G2, but how is it going to compare them? It's going to use the comparator for geometric object, which we can call it C. We could call it whatever we want. C is a good short form for comparator. So that's how we're going to compare them. We're going to compare our geometric objects with the comparator for geometric object. And that means we're going to use the compare method here. So when we run this method right here, here's where we're going to run it. We're going to use G1 and G2 and new geometric object comparator. Well, let's see. Here's the geometric object comparator. Geometric object comparator implements comparator. I'm going to put this all in one line. There's no need for that word wrap there. Implements comparator for geometric objects, serializable. That's just something that is expected whenever you implement an interface. Now here's the compare method that we have to code. And what we're going to do is we're going to compare our geometric objects by area. So we get the area of each one. And then as you can see, here's that familiar code, or at least I hope it's familiar, because it's what you did with compare to. You have to return -1, 0, or 1. And that'll do the comparison. And now we can sort. Using this, we should be able to also sort. In the example that we're looking at, we're actually not doing a sort. We're just going to test geometric object comparator right here. So running our max method here, this result here should give us the largest one. Notice here the way we're using the compare method. C compare G1, G2 greater than 0, return G1, else return G2. So the largest should be, and we can use the get class method to indicate which class was the larger object, and its area by running its get area. So if we run that, here's what you get from get class. The get class method gives you our package name, as you can see, chapter20_555, and then dot circle. So that's the class name. And the actual area of the larger object, the circle, is this number here. So it's a little bit tricky, but we're comparing geometric objects using a geometric object comparator, which we have here with the compare method. We got to put that compare method in there. If we left that out, we would get a warning and we'd have to implement it. Our class would not compile without that. So let's try another example. Sort string by length. Let's try that one. Sort string by length. And here it is, sort string by length. Okay, this time we're just going to work with an ordinary array. An array of strings called cities. As you can see, we've got a couple cities names here, but we're going to sort them, and we're going to sort them by using a comparator. New my comparator. Here we're running a comparator on the fly. We haven't named it. As you can see, we're using the new keyword. So that's going to run the constructor of my comparator. Well, where's my comparator? Well, it's down here. So let's take a look at my comparator. And it's going to implement the comparator interface for strings. So we have to give it the compare method. So we're going to compare two strings. We'll call them S1 and S2. And we'll return the difference between S1 and S2. And by so doing, we should be able to sort these cities alphabetically. So let's see if they are in fact sorted alphabetically here when we use this enhanced for loop to print them out. So here we go. And yeah, they're alphabetically. Dallas. Well, wait a minute. No, we're actually sorting them not alphabetically, but by the length of the name of the city. This is 6 characters. Here we have 7, and here we have 8, and here we also have 8. So just for the heck of it here, why don't we throw Tallahassee in here? It's a nice long one, so we know where that should end up. If we run that again with Tallahassee, obviously it's going to be at the end. because it has the longest length. We're sorting the city names by length. Let's see, let's add a short city name, and we'll add it at the end just to show you that it's got nothing to do with where we put it in the array. So let's go with a short city name. How about Tampa? That's shorter than any of the other names that we have. So that should show up as the first one. Yeah, there it is. So we're sorting them. We're using the arrays.sort method. What are we sorting? Our cities array. And how are we going to sort it? Well, we're going to use a class called myComparator down here. And here's the compare method, which is going to determine how we're going to sort them. And in this case, we're going to be sorting them based on the number of characters in the name of the city, the length of the city name. So let's see what else we have here in our Word document. We have another one, sort string, ignore case. This one does an alphabetical case insensitive sort, and it's going to use a lambda expression. We're also going to use an alternative syntax in the lambda. We're going to use what's called a method reference using a double set of colons. Did you have a question, Habib?
No, sir. Sorry about that.
Okay. Okay. Well, let's take a look at this one. Sort string, ignore case. Here it is. We're going to use this is going to be we're using the list interface, and I'll try to put it on one line and make it a little bit easier to read, I think. Yeah, notice we're using arrays as list, and we've got a number of city names here. So what we're doing here, this is just saving us a number of lines. We're going to do it all at once like this. And now we're going to sort, but we're going to sort using, you can see with this arrow operator here, that indicates that this is a lambda expression, and we're going to sort city names S1 and S2, but without considering their case. We're going to use compare to ignore case. Compare to ignore case method. And let's give that a run. So we should get these sorted now alphabetically. And Atlanta is first, followed by Dallas, and so on. And you notice we changed the case here too. Notice here, Dallas was lowercase and New York was not uppercase like it should have been. But with ignore case, we can we don't have to worry about the case. It does still put them in alphabetical order. Tampa at the end, of course, and Dallas should be following Atlanta. So they are sorted properly. Now we did that with this syntax here, which is running a lambda, but we could also done it with this. Cities.sort, sort the strings, comparing with this method. And here's what's called the, it's called, if you can look back at the document here. It's called the method reference when you use that syntax. So it selects your method. So when you use that double colon, it means use the method compared to ignored case. That's what this means. That's your method reference. So that's another way. And we'll just run it again and show you that it works as well. Works the same way. It's actually pretty cool how that works. Let's carry on if you're okay with that.
Yes, sir, I am.
Okay, good. We'll try sort string by length 2. Let's have a look at that one. Sort string by length 2. I made this one up. Let's have a look at this one. It's kind of the same thing. We've got an array of cities again, and we're going to use sort. We're going to sort cities. And what we're doing is we're going to specify our comparator on the fly here. Comparator.comparing, because there is a comparing method, and then we'll compare them by the length of the name. So we notice we're using string : length. So that means we're going to use the length method of class string to compare these strings. So we're going to sort these city names by the number of names in the name of the city. So we could, once again, we could insert another city in here, like Los Angeles, maybe. Rather lengthy city name. Okay, so let's see what we get when we run this one. Yeah, Los Angeles is at the end because it was the longest name. Tampa is at the first of the list because it was the shortest name in length. So that's pretty cool. So you can sort. What do you want to sort? Cities, the cities array. How do you want to sort it? Based on the length of the name of the city. So you use comparator.comparing, and you specify comparing is a method in the comparator interface.
Mr. Yurt, I have a couple of questions over here.
Okay.
So string : length, the length, is that a method?
Length is a method of class string.
So shouldn't a method call have closing parentheses?
Yes,
Or-
as a rule it does, but not when you use the : not when you use the so-called method reference. You don't have to put in the parentheses for the method. Good question.
Okay,
Very
because
good question.
we're using double colons. Okay.
Yeah, that's right. It's just the name of the method only is length. Actually, that was we had something similar to that back earlier, but when we did
The last problem probably had the same thing too.
yeah, what was the last one we did? Is sort strings, right?
Yes, sir.
Just sort strings. Yeah. So see, that's using the compare to ignore case, but there's once again there's no parentheses on the end.
Okay.
The name of the method is just this part here.
Got it. Thank you, sir.
Okay.
Also, another question. So these are all doing it by default. They're going from smaller to bigger.
Yes, that's right. Which
What
is
if I wanted to do it the other way?
you could tack a reverse on the end of it. We could try that. Let's see. That last one that we did. Like for example, why don't I comment this one out? And right here, I think we can do it right here with a dot. I guess not. I was thinking we could do it right here like this, but apparently not. No. can't do that on the int.
Would a negative S2 work? Yeah, right after the compare to ignore case.
No, I'm going to try S2 and S1 here.
Yeah, I think that worked.
There you go. Yeah, so just reverse these, comparing S1 to S2
Okay.
and make it S2, S1. That other reverse does work for some things, but not for this, unfortunately.
That was a very clever solution, Mr. Yort.
Okay. Let's carry on if that's okay. So yeah, so there is a comparing method that you can use to make a comparator that compares object properties. Again, take a look at page 790 in our textbook, which I think I've got right here. So let's just get to 790 if we can, a couple of clicks. Yeah, there's that compared to ignore case. And yeah, here's that comparing method that you could use. Comparing returns a comparator. So you can use comparator.comparing string and using the length method here. But what's amazing about this is there's also a then comparing method that allows you for a secondary or deeper sort on page 791. So you could compare first by one property and then by another within that first comparison. Chaining reverse to comparing can reverse the sort. So this is the one where you can do that. On page 791, it shows you that. Let's just have a look at that on the next page. Yeah, take a look at this. We're going to use class loan, which I'm not sure if we have that. I think we do. But what we're going to do is we're going to create an array of loans called list by running the constructor of loan twice. So we'll get two loans at different interest rates in different terms and for different amounts of principal. Then we're going to sort that array using arrays.sort. But how are we going to do it? Well, we're going to use comparator.comparing loan.get loan amount. So first of all, we're going to compare the loans by the amount, but then if they happen to have the same amount, we'll compare them by their annual interest rate, which is the first number. And if we put a reverse on the end, it's unfortunate that this went down to the next line because you see there's a dot operator right here at the end of the line. So it was comparator.comparing loan.get amount, then dot reverse, and that would do it in reverse order. So I sure hope we have an example like that. So let's see, I'm pretty sure we do. Let's see what we got in the next page here. No, we don't have anything that works with those loans. But we do have something that we can use here. Let's see. Yeah, I made one up here. Take a look at class human, first of all here. Take a look at class human. So what we're going to do is we're going to create a custom class, right? That's where this is really useful. Okay, so what do we need to know about a human? Well, we're going to make this very, very simple. Name and age. And then we've got a constructor, and we've got a getter for the name and a getter for the age. See, if we want to compare these by name and age, we have to have getters that can access these private attributes, right? So there's class human. Now we're going to sort some humans by name and age. So here's the example. We're going to create just an array of humans called peeps. And as you can see, we're going to create these humans on the fly by running the constructor. So we've got a couple names Jones, and we have a couple names Smith. Common names, as you probably know. Those are common English language names. And we're adding those to an array. So we got, how many have we got? We've got 7 altogether. But we've got 3 Joneses and 1, 2, 3, 4 Smith. We've got 4 Jones and 3 Smith. Okay, so what we're going to do is we're going to sort these first of all by their name, then comparing. Notice here's the second chained method. We're going to use comparator.comparing by the name, and that's going to compare them alphabetically, and then we're going to compare them within that by their age. So after running this line here, they should come out sorted that way. So let's see what the output looks like. So there's the output. So first of all, we should get the Joneses before the Smiths, because Jones is obviously first before Smith alphabetically, right? But now look at all the Joneses. They should be in age order. Yes, they are. Look, 22, 20, 25, and 44. But now look at all the Smiths. They should also be in age order. That is very powerful.
So
So
is that really sorted in order of age?
yeah, it is for me.
I mean,
20,
22, then 20,
oh, I see. Well,
and then 25.
it's because of the A, Jones
Oh,
A.
yeah, you're right.
Yeah, Jones A came first, then Jones D.
Jones
Now
D.
here we have 2 with Jones M. So maybe I
25,
should
44.
maybe I should have made this one with an A here.
No, you're fine. I should have noticed that.
It's okay. I didn't notice it either at first. So, but if we look at the Smiths, we've got 2 Smith Ks, and you'll notice they are in order. So if we were to, let's say we make all of the because there's 4 of them, I'll just make all the Joneses have the same first letter. So I'll set them all to be A. And then we'll see really nicely how this works as a sort within the sort. So we run it again. So now look at all the Joneses, and now they're absolutely in the right age order. I should have just left off the short form of the first name. I should have just left it at last name, so that would have been much easier, much more clear, I guess. But isn't that nifty? You can do a sort and then do a sort within the sort. And by the way, you can keep that going. If you wanted, you could then do a third sort by using then comparing again with a different method, but you'd have to have some plan in mind for doing that. Now, this is really important because you're going to have to do this on your assignment. Now, we're doing it with an array. You're going to be doing it with a generic collection type, probably an array list, but I'm not sure on your assignment.
Generic. So we can use it for an object that we create, right?
Absolutely. Well, here I am. Human is an
You
object.
did create an object.
Yeah, but I only created an array. This could have been an array list.
Okay.
And this would work the same way.
Got it.
Let's see if we have some
Can
more
you
examples.
go back to the class real quick?
Human?
Yes.
Okay.
Okay, I was just looking at the attributes. I didn't know if the A was a char or not. but it looked like it was all on one string. I was gonna see if it makes a difference if you did a lowercase a, just because they're stored differently. But I don't think
Yes, it
would.
would. Yeah, it actually probably would have yes, it would. It would matter. It would make a difference. A lowercase a with a capital A would make a difference. But the most important thing is you got to have some methods in here to use, right? You got to have some getter methods for your class.
Monsieur, do you mind going back to the document for real quick? I have a question over there.
Okay.
So the comparing method can also be used to make a comparator that compares object properties. When you say properties, do you mean the fields that we define in a class?
Yeah, that's right. That's right. The fields or the attributes. Yes.
Okay, so I can compare they're basically variables. I can compare the variables in each class too.
Yes, in each object of that class.
Oh,
Yeah, like
okay.
that's what we're doing with human. Class human had attributes of name and age, and that's what we compared,
Oh yeah, you're right.
right? In our comparator here.
Okay.
You
Yeah,
get
we're
to it.
comparing the name and age. Those are all attributes.
Right. So, but we do that obviously to access the private attributes. You got to use the getter,
Getter methods.
which
Okay,
is a
I
method.
understand
Yeah.
now.
Yeah.
Thank you, Mr. York.
Okay. That's a good question. You're doing the right thing by asking questions. Okay, now lists and collections have some static methods that you can use, and you can take a look at page 792 for a UML of those. And then there are quite a few examples on pages 792 to 794 of the various methods that you can use there. So you might want to take a look at that when you're reading the chapter, focus in on those pages. And then it's got a multiple bouncing ball, but I believe that this is a Java FX program, so we're going to skip that one. But let's look at class vector. Class vector is somewhat like Arraylist. It's a lot like an Arraylist, but its methods are synchronized to be thread safe. This class has been around for a long time. It's a so-called legacy class because it's been around for a long time, but a lot of Java programmers still use it, particularly if they need synchronization. In other words, if they have an object that maybe multiple users are trying to access that particular structure at the same time, well, that would be a problem, because if more than one thread was accessing that object, perhaps the first thread would change the value of one of its attributes, and then what's that going to do for the second thread? The second thread's going to have a problem, right? So to get around that problem, Java coded some classes to be thread safe so that only one thread could have exclusive access to that particular object at any one time. And as soon as it was through with it, then it would release it, and then another thread could capture control of the object to do what it wanted to do with that object. That's what thread safe is all about. Now, if synchronization is unnecessary, Arraylist is a little faster, apparently. There's a UML for a vector on page 799. Use them when you want to avoid the possibility of corruption by multiple threads. That's the only time when you really want to use them. An interesting feature of vectors is they expand by a certain capacity that you can specify in the constructor. So for example, here, we're going to create a vector of doubles. Once again, remember, these are not for primitive types, only for reference types. So we're going to create a vector called v1, which is going to be an initial capacity of 100. And we've also got the expansion capacity of 10. So as soon as we add one more, if we have an initial size of 100, when we add one more, the actual capacity will go up to 110 automatically. And I made up an example called vector 1 for that. Here's one for the Tampa Bay Lightning vector. It's going to be just strings, and we're starting off with an initial capacity of 3 and an expansion capacity of 3. So as soon as we add more than 3, the capacity will go up to 6. So here's our initial 3 that I'm adding, those 3 players. But then as soon as I add Palat, the capacity will go up to 6. It'll add 3 more on. And we can iterate through a vector as well. So we can create an iterator, and then we can use hasNext to go through and print out each one by one. And then we will replace Johnson at index 2. We'll replace him with Stamkos, and then we'll print out. This time we'll use collections.sort. We'll sort them alphabetically. So that should sort the players alphabetically. That's using the collections class. And then we'll create an iterator to go through that. We'll create an iterator called iter2 this time, and we'll go through it. But this isn't an ordinary iterator. This is a list iterator. So we'll use the list iterator to go through it, and the hasNext method. And then we'll report the vector capacity at the end. And then we'll trim it down to size. What trim to size does is it just gets rid of that excess capacity that you don't need. It'll trim it down to the number of elements that you have in the vector. So if we run that, here's the output here. We start off with 3, and then we add Palat, and then we're going to sort. Then we're going to replace Johnson with Stamkos. So after the replacement, as you can see, we've got Stamkos in here. And now we're sorting them too. And sorting them with strings, they will come out alphabetically. So there's the alphabetical order, H, K, P, and S. But the capacity is 6. The capacity is 6 right now. But we want to trim it down to size. So that's what this statement does, and reports after that then that the capacity is down to 4. So other than that, it's pretty much like Arraylist though.
So it just increases the size by double of what I put over there?
Well, not necessarily double. You can specify a different number here. Like I could put a 2 there.
Mm-hmm.
Yeah, and then it would only increase the capacity by 2. And obviously I started with a pretty small initial capacity here.
Okay.
Let's just take a look at the book here. Get to vector. Not sure what page vector is on. Yeah, that's all that JavaFX stuff. Here it is, class vector. And this is what I wanted to get to. This was the UML diagram for vector. Yeah, you see, we've got actually three different constructors here. 3 constructors. You can just have an ordinary constructor, but you can also specify an initial capacity and a capacity increment, as it's called. So look at the explanation here for that one. Creates a vector with the specified initial capacity and increment. So as soon as you go beyond the initial capacity, the capacity goes up by whatever the increment is, by whatever that increment is. Okay, so going back here, class stack. Stack class, it's a LIFO type of data structure, last in, first out. I think we covered this in an earlier chapter, but if you have a stack of books, the last one that you put on the stack is at the top of the book. So if you want to access the stack, you've got to go through from the top down through to the bottom. And the class stack in Java that's part of the collections framework actually extends class vector. When a stack is first created, it has no objects. There's a UML diagram for that in figure 20.1. Peak, just as we learned with stack when we were working with a generic stack back in, I guess it was chapter 19, we had a generic stack. Well, we have peak, pop, and push as well with class stack in the collections interface. And I guess that's on the next page here. Yeah, there it is there. Peak, pop, and push for the stack class, another generic stack. And extends class vector, which was in our very first diagram at the very first of the this document. Right up here. There's stack right here, inheriting from vector, as you can see. Okay, so let's take a look at, we want to take a look at book stack. This is one that I made up because Dr. Liang didn't provide us with one. So here it is. Now notice the type. Notice the type here is stack. So we're going to create a stack of strings for books, and we're going to put some book titles onto the stack by using the push method. That's how you add to the stack, with push. Since we added Core Java 2 as the last one, that means it's on top of the stack. So if we peek, we should see that book. We can also do a search for a particular value and see what we get for that. It'll output a number indicating its position in the stack. And then we can certainly go through the stack one by one. But in order to do that, we have to pop off the books that are on the stack. You have to remove the books from the stack one by one. You're popping them off with the pop method. And at the end of this loop, our stack should be completely empty. So you'll notice that we did get a 2 for where Java in a nutshell was. It was the second one in the stack. And we pop them off one by one. So notice that the last one in is the first one off. So the last one to print is the first one we added, which was the introduction to Java. And at the end, the stack is empty. So if you just want, if you just want to keep store some data in a very simple data structure, a stack is not a bad choice, as long as it's you can search for the item that you want using the search method. Okay,
Mr.
so that's, yeah, go ahead.
We could have used an iterate. Could we have used an iterator class to iterate over iterate the elements in this class?
Well, we should be able to tell that by looking at the diagram here. Let's see.
So vector class.
No, I don't think we can, because let's see, where are our iterators? Our iterators are with our lists. Oh, well, wait a minute. Yeah, maybe we could have. Yeah, because as you can see, if you follow the inheritance stack goes up to vector, which goes up to abstract list, which goes up to list, which has an iterator. So we probably could. So let's see if we can. So what I'll do is I'll comment this out, right? Let me comment this out. We'll try it. It's a good question. So let's give it a try. So we'll comment that out. What we'll do is we'll instead create an iterator for that. So we'll go with iterator. And it's going to be an iterator for strings. I'll call it just IT. Now I have to use my collection object, which is books. Books dot. Yep, there it is, iterator. Okay, so we can now use our while is usually what's done. While IT dot has next. We want to print out IT dot next. And that should print them out as well. So let's give that a try. However, look, it doesn't pop them off.
No.
So that's good. I'm glad we did this. So we can use an iterator to go through the stack without having to pop them off. So the stack is still in place. Okay, so the stack is still in place. Now we can demonstrate that kind of nicely right here too, by just trying books.peak, right? And we should find out that the top book is still on the top of the stack. Yeah, there it is. Core Java 2, the last one we added, is still at the top of the stack. So I'm glad you brought that up. So you don't have to go to pop everything off the stack to go through the stack. You could go through it with an iterator, as we did here. Very good question.
Thank you, Mr. York.
All right. Bonus points for you, Habib. Nice job there. All right. We're almost through this, I think. That was vector stack. Oh yeah, so now we have to look at queue. Queue. We've all been in a queue before, right? At a fast food eatery or somewhere. Or the worst queue in the, what's the worst queue in the world?
Airport.
Say what?
Airport.
At the airport. Yeah, airport is bad. You're right. You're right. I was thinking of tech support, but you're right. Airport is bad news. Whew. It's not too bad at Tampa. I got to say, for Tampa, that's not too bad. But every other airport I've been through has been terrible. And apparently, they're going to make Tampa even better.
It only took me 2 hours to get through Tampa Airport.
It did. Wow.
Yeah.
Wow. That's terrible. I had a lot of trouble in Toronto, coming back through Toronto. Oh my God, nightmare. Anyway, what is a queue? Well, you know what it is. It's unlike a stack. A stack is a LIFO type of collection. Well, a queue is a first in, first out, a FIFO type of collection. First in is first out. First one in the queue is the first one that's served. So we've got a figure on page 801 that shows the methods of queue. We could take a look there. Let's have a look at that on page 801. for class Q. Okay, there it is. Now look, quite different methods here. You've got offer, inserts an element into the queue. So instead of add, you use offer to add onto the queue. Poll retrieves and removes the head of the queue. So poll is kind of like next customer, please, right? That's basically what the poll method is for in a queue. It's removes the head of the queue. So that's kind of like, may I serve the next customer or something like that. Okay, and remove removes the head of the queue. Peek looks at the top of the queue but doesn't actually remove it. And then we also have element, which retrieves but does not remove. So you've got some different methods. The most often ones you're going to be using are offer and poll. And as you can see, this once again inherits from the collection interface for a queue. Very interesting word, queue. Can't think of too many words that have 4 consecutive vowels in them. That's one of them. But of course, it's from the French word for queue.
Monsieur, this is first in, first out, right?
That's right. That's
So
right.
where is this ever going to be useful?
Oh well, if that's what you need, well, maybe you have a maybe you're going to use Java at the airport. I mean, it's possible, right?
Yes, yes, sir.
You know, so like you put yourself in the queue, but maybe what you do is you go sit in the sitting area. So maybe this is more like my doctor's office, for example. If I go to my doctor's office, I think I have a unique appointment at 9 o'clock, but no, I don't. There's 25 other people that also have a 9 o'clock appointment. It's whoever's the first one that signs in is at the head of the queue, or the first one that goes to the desk. It becomes the first one in the queue. It seems like to me, anyway. Maybe I'm wrong about that, but that's the way it seems.
You're not wrong.
Yeah, and so this is where you could use it in a case like that, I suppose.
First out.
So just going back to the document here. Linked list is a concrete implementation of a queue. So you can use it to create queues. You can see that by looking at the the collections framework inheritance diagram. Now a deck or double-ended queue, that's what a deck is. So that means you can insert or delete at both ends of the queue. And it's a sub interface of queue. We've got just one example here called test queue. Let's have a look at it. Here it is. Here it is. So we're going to create a queue of strings called queue, and we're going to use linked list to make it. And notice we're using the offer method. So we're going to add some state names here, as you can see, to the queue. So Oklahoma is going to be at the head of the queue, and Texas is at the tail end of the queue. So what we'll do is while queue.size is greater than 0, we'll run the remove method. So that'll return the elements in the queue one by one, starting from whoever's at the head of the queue. And after this is done, I guess the whole thing is going to be empty. But we have to use the size method here. So let's see. There's what you'd expect to get, I guess. Okay. So let's see what happens if I put poll here instead of remove, using the poll method. Same thing. But retrieves and removes, so it does the same thing as remove. Now, something that's a little bit weird is there's also a priority queue. A priority queue inherits from the queue interface, and it uses natural ordering to sort. So it does a natural ordering of sorting. Now, if you're natural ordering strings, that means they're going to be sorted alphabetically, naturally. Okay, and we do have one example called priority queue. So let's take a look at it. Priority queue. We take a peek at that. Here it is. So once again, we're going to start off by making a priority queue this time, running the priority queue constructor. And we're going to put some states in the queue. And now we're going to look at it using comparable, using the comparable interface. While Q1.size is greater than 0, we'll remove it. So we'll print it out. So that should print all in one line. Notice that's a print, not a print line. And then we're going to make another priority queue with the original. This is what's going to be called Q2. And it's going to use collections.reverse order. I'll put this all in one line, be a little easier to follow. And now we're going to run this one with a while loop down here using a comparator of reverse order. So it just reverses them, as you can see. Yeah, priority queue is it's actually not covered very well in our textbook, but the natural order is alphabetical.
So
where you got to watch
priority
it,
just reverses it.
Yeah, well, just because of this.
Oh, the reverse
Yeah,
order. Okay.
Yeah. Now, what's kind of weird about natural ordering is, like, let's say we're talking about addresses here instead of cities. So I'll try it with this one here. So instead of Oklahoma here, I haven't done this in a little while. I hope I get this right. I'm going to go with some street addresses, but they're all going to be on the same street. Okay, so I'm going to go with 91 Elm Street. And then we'll go with 2 Elm Street. And then we'll go with 22 Elm Street. And then finally, we'll go with 100 Elm Street. We'll try. Now let's see what we get on this one here. So let's see, look at the order. We've got 91 Elm Street, followed by 22, followed by 2, followed by 100. Now, those don't look like they're in any order,
No.
but they are, in fact, in order.
How?
Well, what's considered the lowest here is the 100, because it starts
Because
with
of
a 1.
binary. Oh.
Well, it does it character by character, and the 1 is lower than the 2 or the 9. So if we were in reverse order, this is the lowest one. And because this starts with a 9, it's a higher one. It's higher than 100 because 9 is more than 1. So it shows up first. 22 and 21 are, I guess, 22 and 2 are kind of understandable, I guess.
Because it's reversing the string.
That's right. So 2 is less than 22. So that would make sense, I guess.
Gotcha.
So natural ordering can kind of fool you in some cases, because if you were walking down a street, you would expect the numbers to be in order, but these aren't. So natural ordering can throw you off. So you got to be careful of that. Okay, well that's it for this chapter, chapter 20. You're going to have to do some. I think you're going to have to do some work with comparator and doing some sorts and then sorts within sorts, comparing and then comparing. I'm pretty sure you have to do that for your assignment for this chapter. Let's see if I can. I think we got another example that we can show you here. So I have not imported yet. Back on our course page, which I'm not sure if it's still available. It looks like it's not, unfortunately. But back on our course page, I think there was another one that we could import. So I'm going to see if I can import it right now. I believe I downloaded it. So I'll search for it. And yeah, I think we're looking at 5. Yeah, we're looking at 555. So I'm going to look at this 535. Let's see what's in this one. Might be some interesting examples in this one. So what I'll do is I'll just shut this one down. I'll do close project on this one. That'll just shut it down and get rid of all the class names. And then here's the one that I've just inherited, or just imported, I should say. And as you can see, it's giving me a problem. I got a red exclamation mark up here. Well, I believe it doesn't have the correct version of Java. So I'm going to go with configure build path. And yeah, it's Java 8. It's pretty old. It's because it's from an older semester. So what I'm going to do is I'm going to remove that. And then I'm going to add a new library, a new JRE for the current JRE that I have, which is Java 16. And that should fix up that problem. That problem should go away, I think. Well, actually, we also have a problem here because once again, this is a Java FX program, so I'm going to get rid of this one completely, and then we'll be fine. No more errors. So let's just take a look at another comparator one that I think we made up for you here. Test comparator. Let's have a look at this one. That's not the one that I was hoping for. I thought we had one that would compare, but I guess we don't. So why don't we try something along the lines of what you're going to have to do for your assignment? Unfortunately, I have to go and find my course page again. So let's see if I can get there. Just a couple of clicks and I will be there, I think. And here's our assignment for chapter 20. So we have to create a class car, which has these attributes: VIN, VIN, make, model, year, and price. By the way, this like the concept of VIN, the vehicle identification number, Do you know where that's located on your car?
On the windshield,
That's
front
right.
windshield.
That's right. On the you can see it on the dash through the windshield, right?
Yes, sir.
And I don't know if you know, but that tells you everything about that car. That VIN isn't just a sequential number. Certain numbers at certain places tell you all sorts of things about that car, like what's been installed in that car, where it was made, like where it was assembled, for example, right? All kinds of information about the cars in that VIN. It's really interesting. I worked at General Motors one summer when I was a student, and I learned all about that. It was pretty cool what VIN numbers are all about. Anyway, enough about that. But so here we have a class car, and then we've got a constructor, we have getters. Now in the executable class, what we want to do here is we want to sort it. Here's the, as you can see, we're going to make an array list of, first of all, we're going to make an array of 10 cars. And we want to make sure that we have quite a few that have the same last year's, but different prices. Because what we're going to do is we're going to sort, we're going to create an array list from the array, we're going to shuffle it, and then we're going to sort it by year and then by price. So that means we're going to use comparing and then comparing. So I just wanted to make sure that you're okay with that right there. That's the tricky part. But I think you can do it okay if you look at that one example that we had. Maybe we could try to do something. Why don't we, let's see. I got an idea. Why don't we, just dreaming one up here. Why don't we make up a new class? So yeah, you can follow along with me while we make this, and this will be a very good help for your assignment. So what I'm going to do is I'm going to make a new class called property. Thinking like a realtor. Okay, like real estate. Class property. This is going to be a data class, so I don't want a main method, but I do want a couple of attributes. So I'm going to go with private int. This is just going to be for the number of bedrooms in the property. We're thinking about a house, of course, and then private double price. I'm not even going to go with anything else. Obviously, there's many more attributes that you'd want to have for a property, but I just wanted to stick with those because what we'll do is we'll sort by price and then by the number of bedrooms for properties with the same price, just as an example. So let's create our constructors, which we can do pretty quickly right away by constructor using fields. That gives us one, and then we can create our getter. What we need are getters for the beds and the price. And then I guess we also need a toString. So what I want to do is get a getters and setters, but I don't want both. I only want the getters for each one. So that'll get me my getters. Now I do want to get a toString for each class too. So I'll generate the toString. And guess I chose the wrong choice there. I'll try that again. Generate the toString. Here it is. And I'll just leave it as that. And we'll go with this pretty crude one here. Okay, well, I won't even bother changing it. We'll just leave it like that, which will be very crude looking output, but we'll leave it like that because what we're trying to focus in on here is how to do a sort and then a sort within the sort using comparing and then comparing. So now let's make an executable, and we'll make a few properties with the same number of bedrooms but different prices on some of the properties that we create. So we'll go with a new class, and we'll call it what will we call this new class? We'll go with we'll call it real estate. Class real estate. And of course, I should capitalize the E, capitalize the first letter of each and this is going to be an executable. So I'm going to give it a main method. Okay, so let's create a couple of properties, and we'll do it on the fly here. So we'll go with property, and we'll make it an array. We'll call it props equals. And what I'm thinking of is I'm going to use the array initializer syntax. So what we'll do is we'll just specify some properties here on the fly by using the constructor. New property. And now what we have to do is we have to give them a certain number of bedrooms. So I'll go with 3 bedrooms and 125,000. That'll do for one property. And then let's just do that for several more. New property. And we'll try to get, again, the same number of bedrooms, but a different price. So we'll go with 135,000. And we'll add a few more. Now what I'll do is I'll just copy these and edit them just to make it a little faster. Get a whole bunch of them in here. Okay, so let's make this 2 bedrooms and 125, and we could let this one be 2 bedrooms and 135, and we'll make this one 2 bedrooms and 115. And this one would be 3 bedrooms and 145. This one will be 3 bedrooms and 105. And for this one, it'll be 3 bedrooms and 150,000. So we've got, how many we got here? We got 8 properties. Okay, 8 properties. So now what I would like to do is I'd like to create an array list from those. Okay, so let's make an array list from those. So that would be array list. Array list of properties. Array list of type property. Array list property of I'm going to think like an agent who's selling these things, so I'm going to call it listings, because that's what they call it. If you're a real estate agent, they keep track of their listings. Here's where my T went, and so I'm going to go with new array list. New array list, and inside my parentheses, I'm going to use my arrays class, capital A arrays dot as list. Missed it. Arrays dot as list, and I'll put my props array in here. Now I'm going to get an error message on this because I have to, the class array list array is okay, but arrays is not. So, oh yeah, here it is up here. So array list property, new array list. Okay, so what's the error message here? I think I'll just do a source organize imports. This should get rid of any issues. Yeah, we've imported array list now. So we've got all the classes that we need. So good, we've got our array list. Now, let's sort this thing. And what I'd like to do is I want to sort it using the collections class. And I want to sort them first by bedrooms, then by price. Okay, so we'll go with collections dot sort. Now, what do I want to sort? I want to sort props, my array list. And how do I want to do it? I want to use a comparator. So I'm going to go with comparator dot comparing. And I think what I'll do is I'll use the method reference approach. So what I'll do is I'll use class property, and I want to use the get beds method, right? That was the getter for the beds, I believe. Get beds. Let's just verify that by looking at our property class here.
Yes, so get that.
Yeah, get beds. Okay. Okay. But then we want to also do that. We want to chain that with the then comparing dot then comparing with class property and using the get price method. So let's see, we do have something wrong here, but I'm not sure what it is. Thought that would be okay.
Monsieur, don't we have to implement the interface?
I'm doing it right here by using comparator. Oh, well, I have got it imported up here. Let's see what the error message is. Not applicable. Not applicable, apparently. So we have to set that up. Let me just check the syntax up here for geometric object comparator. This isn't helping very much. How did that go? Okay, I'm just going to go back to the textbook for a second here, because obviously I'm missing something. And we'll see where a comparator was used. And according to my document, let's just see where that was. Now let's take a look at page 791 in the textbook here. We should get some good help here.
Monsieur, instead of writing props, if you write the object name, the array object, the error goes away.
Oh, listings.
The line after that.
Yeah, yeah. I put props instead of listings. I use the array name instead of the Arraylist name. My bad. Yeah, yeah. This should be listings.
Listings.
Thank you. That solves the problem. Excellent. Now we could have sorted this too, but it's the array list that I wanted to sort. So that's where class collections comes into play. Okay, so let's we could go through this in various ways. Why don't we try using that that for each method? That should work pretty well. So let's go with listings dot for each. And what we want here is E And right here, just put the letter E, and that should run the to string for each object. Yeah, so just forgot the E there. Now, if we scroll this up, let's see, are they in order first by beds, then by price? Well, definitely they're first by beds. As you can see, the twos are before the threes. Now look within the beds. Yes, they are in order, 115 to 125. Now look at the 3 bedrooms, and they're all in order.
Yeah, it worked.
Yeah. So you're going to have to do something like that for your assignment, I believe.
Yes,
Sorry
sir.
that-
Mr. Yurt, I
Sorry,
don't
I
want to
stumbled
keep
on
you.
that a little bit, but go ahead.
Could you possibly explain to me what's happening in that line collections dot sort listings, the line before the print statement?
Right here? Yeah.
Yes, sir.
Yeah. Well, we're going to sort our listings array list. How are we going to sort it? First of all, by the number of bedrooms.
Okay. And then by the price.
Right. Within the first sort. Notice it says then comparing.
Then
So
compare.
first we're going to sort by bedrooms, then by the price within the bedrooms. So that's why all the bedrooms get sorted.
Okay.
Within the bedrooms, we've got them by price.
I got it. Thank you, sir.
Okay. That's why it was important for us to have the same number of bedrooms. In order to see if this worked, I had to have quite a few properties with the same number of bedrooms.
Got it.
And you know, it's got nothing to do with the order that I put them in. I mixed them up with 2s and 3s when I created the array.
Yeah, it's a little mixed up and
Yeah.
sorted it perfectly.
Yeah. We could print them before the sort. I guess I could copy this line and paste it in here, and we could see them before the sort. Oh, well, I'm not right there. I have to after creating the list. After creating the list here, we could paste it in here. And then after doing the sort, what we'll do is we'll just do a system.print line here. And we'll put inside this one, we'll say after sorting. And then we'll see multiple outputs. The first set won't be sorted, obviously. Yeah, so there they are, just as we created them, in no particular order. And then here they are after being sorted. And interestingly enough, now if we had a third attribute that we wanted to sort them on, we could. We could
Okay.
do that too as well. You just have to use then comparing
Then
a
comparing.
second time. Yeah, so then you just have to add another then comparing here out at the end.
Sure.
And I just wanted to try reverse here. No, doesn't like that. Okay, so that's it for chapter 20, folks. Now next week, I just want to make sure everybody knows that next week is there's actually no class because it's Thanksgiving Day next Thursday. And the college is closed next Wednesday, Thursday, and Friday, by the way. So if you have any classes on Wednesday, Thursday, and Friday, they are all canceled. Okay, no classes next week on Wednesday, Thursday, and Friday, only Monday and Tuesday.
Okay.
Okay,
Yes, sir.
all righty. All right,
Thank
so
you, Mr. York.
have a good one. So what I'm going to do is I'll try to make up a good video showing you what you need to know about chapter 21, since we don't have time for a Zoom next week.
Chapter 21 is maps.
That's right, maps and sets. Yeah.
Yeah, that would be really helpful, Mr. York. Thank you.
Okay. Okay. All right. Take care, folks. Have a great weekend, and I will send you a link to this recording.
Thank you, Mr. York. You too.
Okay. Take care. Bye bye now.